Hi, today we're looking at section 8.2, graphs of other trig functions. So they start us off with the tangent function, which is defined as tangent of x equal to sine over cosine. Because the cosine function is in the denominator, the tangent function is going to be undefined whenever cosine is 0, because you cannot divide by 0 in math. So that's going to create undefined points, which result in vertical asymptotes. As you can see, the asymptotes are here. You can see that they're dotted vertical lines. So tangent graphs will always have asymptotes, as you can see there. All right, let's look at the characteristics. The period, unlike sine and cosine, the period of the tangent function is only going to be pi instead of 2 pi. The domain is all real numbers except where there's asymptotes. And you can see that the asymptotes occur at every multiple of pi over 2. So this is what they mean by every multiple of pi over 2. Every pi over 2 plus a constant of pi. That's what the domain is going to be. The range is going to be all real numbers since the graph goes indefinitely upward and indefinitely downward. So that's the range, all real numbers, which we can write as negative infinity to positive infinity. The asymptotes occur at the odd multiples of pi over 2, as you can see by the graph. If you look at all the multiples of pi over 2, they're going to continue to appear at every multiple of pi over 2. So let's write that there. Pi over 2. Okay. Tangent is an odd function, which means that tangent of negative x is equal to the negative tangent of positive x. The graph is symmetric about the origin. Any function that is odd will always have origin symmetry. Okay, here is the general form of any tangent function. And just like the sine and cosine, the letters A, B, C, and D will determine what the graph looks like. So let's move on to the next page. The middle is is in the middle, and then you have the asymptote on the left and the asymptote on the stretch factor. Because the tangent function has no max or minimum, it has no amplitude. Instead, A is referred to as the stretch factor. The period, instead of 2 pi over b, is going to be defined as just pi over b. So there's a new formula for tangent. The phase shift is still the same, c over b. Okay, so let's look at this first example. Determine the stretch factor, which we're still going to call A. A is, well, let's go over here and list off what A, B, C, and D are. A in this function is 3. B is pi over 6. There is no C, which means it's 0, and there is no D, which means that is 0 as well. Okay, so the A, which is the stretch factor now, is going to be the absolute value of 3, which is 3. That's the stretch factor. Okay. The period is pi over B, or absolute value of B, which in this case is going to be pi over 6, which becomes pi times 6 over pi since you multiply by the reciprocal. And then that gives us 6 as our period. Okay. And finally, the phase shift. Phase shift is C over B, which will be 0 over pi over 6, which is 0. That means there is no phase shift. And I forgot to mention the increments, so let's go back to the increments, which is p, the period, over 4, which in this case is 6/4, which is 1.5. So our increments are going to go by 1.5. All right, so let's start with the phase shift. So as you can tell by the tangent graph on the previous page, right, so let's point. Since there is no phase shift, our point will be in the middle. So that will be right here at 0. And then our increments are going to move by 1.5. So let's go to the left first. 1.5 to the left, and then another 1.5, which would be -3. And then if you go 1.5 to the right, and then another 1.5 to the right, that's going to take us to 3. So these are the asymptotes. Okay, and tangent goes in this direction. So since the stretch factor is 3, we're going to go up 3, down 3, 1, 2, 3, and then 1, 2, -3. And now we can put our points. At the first increment, we go up 3, and at the increment to the left, we go down 3. And then we simply connect those 3 points in this orientation, and that is our tangent graph. Checking our answer on Desmos.com, you will see that our graph looks just like the graph on Desmos, so we got it correct. Let's move on to the next problem. So let's start off once again by writing out the A, which is -2, the B, which is pi, the C. Well, we do have to be careful here. Let's rewrite the function so that there's a minus instead of a plus. So it's going to be y equals -2 tan pi x minus -pi minus 1. So the reason I did that was because you don't want a plus here because the general form always has a minus. So if you have a plus, you can force it to be a negative by just making the following number a negative. So double negative makes a positive. So whenever you have a plus, just change it to double negative. That way your C becomes clear. The C must be -pi in this case. And the D is -1. So now we can continue with our, let's start with the midline. So since this one does have a midline, it has a D, so the midline, just as it was with the other problems, is going to be the D. So midline is y equals -1. So let's go ahead and put that in. Okay, so midline, here we go. Okay, so we got our midline, y equals -1. Now we can go with our stretch factor, which is going to be absolute value of -2, which is +2. The period is pi over b, or absolute value of b, which in this case is pi over pi, which is 1. The phase shift is c over b, which is going to be -pi over pi, which is -1. Our increments are going to be p over 4, which is 1/4. Okay, so it looks like we have everything we need. Midline, stretch factor, period, phase shift, increments. So we start with our phase shift, which is -1. Let's put our -1 down. Then you're going to go 2 increments to the right and 2 increments to the left. So if you add 1/4 plus 1/4, that's going to be 1/2, right? So let's start at -1 plus 1/4, which is 0.25, plus 1/4 again. You're supposed to do that 2 times to get to the right. So that's going to be -1 plus 1/2, which is -1/2. This would be -0.75. If you go in the other direction, you're going to subtract 0.25, so -1 minus 1/4, which would be -1.25. And if you do that one more time, you're going to get -1.5. All right, so now we can draw the asymptotes. The asymptotes are at those two ending increments. All right, now we can start to draw our graph. Right in the middle at the phase shift, at the midline, you put 0, 0, right there, right at the middle value, which is -1. And then tangent, because there is a negative a, instead of the usual tangent, which goes in this orientation, it switches orientation because of the -a. So instead of going this direction, it's going to go the opposite direction. So at this increment, we're going to go up 2 values because that's your a. So 1, 2. So that value would be 1. And then if you go down 2, it'll be 1, 2, which is -3. So at this increment, we're going to go to 1. Oh, I'm sorry, down 1 because of the -a. And at the other increment, you're going to go up to 1. Okay. Oops. This point should have been -2 down because of a. So it's -3. There we go. Let's check our answer with Desmos. And as you can see, it does match up with our graph. So it looks like we got that correct. Let's move on to the next problem. Okay, so the next page is going to talk about secant and cosecant functions. As you can see, secant is defined as 1 over cos, and cosecant is defined as 1 over sine. So we're going to graph the reciprocal functions. So for secant, asymptotes occur where cosine is equal to 0, which is every multiple of pi over 2. And cosecant is going to, asymptotes will occur for cosecant when x is equal to 0. So that would be at multiples of pi. So any multiple of pi, that's where you will have an asymptote. The period for both secant and cosecant is the same as cosine and sine, which is 2 pi. So this is what the graphs of cosecant and secant look like. So you want to graph this, for when you're graphing secant, you want to graph the when you're graphing secant, you want to graph the cosine function because the cosine function acts as your guide for these branches, and the branches are the secant graph. Similarly, when you're graphing cosecant, you first need to graph the sine function, which also serves as a guide, and then you can draw the branches once you have the sine function in place. So you will see how that works in just a bit. So similarly to below, let's see, to sketch the sine or cosine graph, you will have to, to graph the secant and cosecant graphs, you'll first have to either graph the cosine if you're graphing sec, or the sine if you're graphing cosecant. All right, so draw vertical asymptotes where the guide graph crosses the x-axis or the midline. We'll just stick with the midline. So let's go straight to our problem, our exercise problem. Here it is. Okay, so let's start off with listing out the A, B, C, and D. A is -2.5. B is 0.4. As you can see, there is no C and there is no D. So before we graph this, we're actually going to graph the cosine because cosine is the reciprocal of secant. So let's start this off by doing that first. So amplitude is going to be absolute value of -2.5, which is 2.5. Okay, midline is y equals 0 because there's no D, which means the graph is just going to go right, the middle of the graph is the x-axis. All right, the period is going to be 2 pi over absolute value of b, which is 2 pi over 0.4, which turns out to be, let's see what that is on the calculator, If you have your calculators, go ahead and find out what that is. Turns out to be 5 pi. Okay, and now we're going to go ahead and do the increments, which is p over 4. In this case, it's 5/4 pi. The phase shift is the last thing we usually do. That's going to be c, which is 0 over b, which is 0. So there is no phase shift, which means the graph will just start at 0. So let's start that. Let's label our x-axis. So we're going to start the graph at 0 because that's your phase shift. Your phase shift is the starting point. And then you're going to increase by the increment. So the next point would be 5/4 pi. And then if you add 5/4 to that, you're going to get 10/4 pi. If you add 5 to that, you're going to get 15/4 pi. And if you add 10 to that, you'll get 20/4. 20/4 is really 5 pi. All right. I didn't simplify this fraction, but you can if you'd like to. The fractions that can be simplified, you can if you'd like, or you can just leave them as I did, because it just makes it easier to add 5/4 each time if you leave the denominator as 4. Okay, so let's see. Our midline is 0, so that's just right through the x-axis. We're going to go up to 2.5 and down to 2.5, so let's write the tick marks for the y-axis. 1, 2, positive 3, 1, 2, negative 3. Because we are graphing secant, that's the reciprocal of cosine. Cosine doesn't start at 0 like sine does. Cosine starts at the a. The a is negative 2.5, so I am going to start down at negative 2.5, which is right here. For the next increment, you go to 0. The next increment, you go up to 2.5, and then back down to 0, and finally back down to 2.5. That completes one period for cosine. We can put the asymptotes in. The asymptotes occur at the x-intercepts. So there's one asymptote, one x-intercept of cosine, and the other asymptote would go at the other x-intercept. And finally, we can draw the branches. The branches are the graphs of the secant function. So let's graph those. So you pretty much use asymptotes as your guide, and then you just approach the asymptotes as close as possible without actually touching them. So here are the branches for our secant graph. Now let's check our answer with Desmos. And as you can see, it does look like we did that correctly. All right, let's move on to the next question. Okay, let's start this off once again by writing out what A, B, C, D are. A is 6, B is 4, C is, careful, we have to rewrite this function with a negative, not a positive. So let's rewrite this function, y equals 6 cosecant 4x minus negative 2 pi minus 5. All right, so C is negative 2 pi. That's the whole reason why we do this double negative, so that you can get the C correct, the sign correct. D is equal to negative 5. Okay, so let's start with the midline. So the midline, as you can see, is D, negative 5. So we'll write that out. Midline is y equals negative 5. Amplitude is absolute value of 6, which is 6. Period is 2 pi over absolute value of b, which is pi over 2. Increments, we're going to divide the period by 4, which is pi over 2 divided by 4, which is pi over 8. Lastly, phase shift, c over b, turns out to be negative 2 pi divided by 4, which is negative pi over 2. So now we got all the information we need to proceed and graph this function. So remember, we are graphing the sine function first because we're graphing the reciprocal of cosecant in order to have the graph to guide us, and then we can just fill in the branches. Okay, so let's start with the midline, which is at -5. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, -5. 1, 2, 3, 4, 5, +5. Our midline is going to go right through -5. So I'm going to dash that. Okay. Let's label that y equals -5. Our phase shift is where we start our graph. So remember, the start of the graph is always the phase shift. All right, so in that case, we're going to start at -pi/2. Then we're going to go to the next increment by adding pi/8. So let's add, pi/2. You start with -pi/2, which is the starting point, and then you add the increment to that. If you do that, you should get times 4 times 4 LCD. -4 plus 1 is -3 pi/8. So that's going to be the next one. Then if we add pi/8 again, you're going to get -2 pi/8. That's going to be the next one. And then if you add pi/8 again, you're going to get -pi/8. And then one more time, if you add pi/8 to that, you do get 0. That's the final point. So that's where your graph ends. So now we have the starting point and the end point. Because we're drawing sine, that means we're going to start at 0 at the midline. So we start at 0 at the midline, which is here for sine. Whoops. Let's do that one more time. At the 0 at the midline is right here for the first point at the phase shift. And then you're going to go, sine goes up first if A is positive. Notice that A is +6. So that means you're going to go up 6 units from the midline. So if you go up 6 units, that's going to take you to +1. Because we're at -5. And if you go up 6, that'll take you to +1. So at this point, you would go up to +1. And then the next increment back to 0. Then at the next increment, you're going to go down 6 units. So if you go down 6 units, you're going to have to extend this out a little bit more. 1, 2, 3, 4, 5, 6, way down here. So, and then finally back to 0. So here is our graph. This one should be dashed. Asymptotes at the points of intersection with the midline, which are kind of like your x-intercepts if you think of the midline as the x-axis. And once you have the asymptotes in place, now you can draw the branches. The branches are just touching the tips, the valleys, and the peaks, or the peaks of each of those humps. So there they are. Great. All right, let's move on to the next topic, which is cotangent. So the cotangent's very similar to the tangent function. So the period is going to be the same as the tangent, which is pi. And there's going to be vertical asymptotes that occur at every multiple of pi. So pi k, where k is an integer. And just like tangent, the symmetry is going to be over the origin because it's going to be an odd function. Okay, let's move on to the last problem. Let's start off with listing out our A, B, C, and D. A is 4, B is pi/8, C is positive pi/2. See, in this case, it's already minus, so you don't need to change it to a double negative. So it's simply positive pi/2. And then D is -2. Okay, so let's start with the midline. Midline is -2, y equals. Okay, there's no amplitude because it's very similar to tangent. So instead of an amplitude, see how there's no amplitude? There's no max or min. It's just going to be the stretch factor. So SF for stretch factor is going to be 4, absolute value of 4, which is 4. All right, the period is the same as tangent pi over absolute value of b, which is pi over 8, which means if you multiply by the reciprocal, you'll get the cancellation of the pi's, which leaves us with 8. The increments are going to be period over 4, 8 over 4, which is 2. Okay, and finally, the phase shift is going to be C over B. So it's going to be pi over 2 over pi over 8, which is pi over 2 times 8 over pi, which is 4. Okay, now we have everything we need so that we can start to graph our cotangent function. So let's start with the midline, which is going to be at, our midline is at -2, so 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So our midline is at -2, so let's draw the midline with the dashed line. Okay, now we're going to draw our first point is going to be our phase shift, which occurs at 4. So that's going to be the middle of the graph. So let's go here, draw our tick marks. 1, whoops, that's not what I wanted to do. 1, 2, 3, 4, 5, 6, 7. Okay, so from 4, since 1, 2, 3, 4, that's the middle of the graph. That's your phase shift. The phase shift represents the middle of the graph for cotangent and tangent. Then you're going to go to the increments, 2 to the left and 2 to the right. So if you go twice to the left, you're going to go 1, 2, which is 2. And then if you go another increment, 1, 2, you'll be at 0. So that's because the increment is 2. Now you go to the right. If you go 1 increment to the right, that's 6. And if you go 1 more increment to the right, that's going to be 8. So the asymptotes are occurring at the 2 endpoints, which is 0 and 8. All right, and then you put your midpoint right on the midline, which is at 4. And then if you notice by the cotangent, look at the orientation. The orientation is drops down to the right, rises left, drops to the right. So our graph, so long as A is positive, which it is, as you can see, A is positive, so we're going to keep that orientation. So the orientation should look like this. At this interval, you're going to go up to 4, stretch factor of 4 from the midline, so it's 1, 2, 3, 4. So that's going to occur at 1, 2, because our midline is -2, and you got to go up 4. At the other increment, you go down 4. So if you go down 4, it's going to be 1, 2, let's see, 2, 3, 1, 2, 3, 4, which is this point right here, which is 1, 2, 3, 4, 5, 6, -6. So at 6, you go down to -6. And there is your cotangent graph. And that completes this section.